parent functions of graphs. The parent function of a graph is the basic graph of that form that has not been shifted or distorted in any way. So some of the first essential basic ones are linear and quadratic. The linear function is just a line that passes through the point 0, 0, and it goes up 1 over 1. It's just the line y equals x. So we all know how to graph that one. Y equals x, goes through 0, 0, up 1 over 1, and then draw a line. Quadratic, slightly more difficult, just in the sense that it's x squared. So our parent function is y equals x squared. And how we would graph that is the origin goes through 0, 0, and then it goes up to 1, 1, and negative 1, 1, and then 2, 4, and negative 2, 4, and then it's a curve like that. So that would be a way to graph that. Next, we have the cubic function. Okay, so instead of it being an x squared, it's an x cubed. All right, the difference between that one is the x squared went up in a U shape. The cubic is going to go down on the left and up on the right. All right, so if we were to graph it, it's still going to go through the point 0, 0, still going to go through the point 1, 1, but going to go through the point negative 1 as well. And then it's going to go that same way. All right, and then the next point would be 2, 8. Way up here, and so on, and negative 2, negative 8. And that's how that one will look. It'll just kind of hump right at the middle there. Now, the square root function is a little different. It's kind of like the quadratic function, except it turns on its side, but it's also only half the quadratic function. Because I did not put the plus and minus before the square root of x, it is just the top part of the graph. So it's just going to be this part of the graph right here. You are not going to draw the bottom part of the graph. So it's going to go through 0, 0, but then it's also going to go through 1, 1, and then 4, 2, just like if it was the flipped up, but it's only going to be the top half of the graph. Okay? And the cube root function is actually going to be the entire thing flipped on its side. All right, the entire cube, x cubed, flipped on its side. All right, so this one's a little different as well, because it doesn't matter because it's an odd function, so the entire graph will be drawn. All right, so it's going to be the cube function turned on its side. The next two functions are a little bit more difficult, the exponential function and the logarithmic function. The exponential function always goes through the point 0, 1, and then it starts low, never crosses the x-axis, so the x-axis is an asymptote. It means it approaches but never actually reaches that axis, and then it starts low and then it rises infinitely. Okay, now we already studied that the inverse of an exponential function is a logarithmic function, so that means it's just the opposite. So it's going to flip over the line y equals x. So instead of it being like that, we're going to approach our y-axis, and then we're going to go up forever. All right, but we're reflecting it over this line right here, our exponential function. So we're going to have an asymptote at the y-axis. And this one also is going to pass through 1, 0 right there. So that would be the critical thing to remember. The last graph that we're going to talk about in here is the rational function. Rational functions would be the parent function y equals 1 over x. So if you ever have x in the denominator, then the parent function is this rational function right here. And it's a two-part function. It has asymptotes at both axes because it cannot reach either axis. And it's going to get closer and closer and closer, and our center point is kind of still going to be the origin, but it's never actually going to go through the origin. So it's going to go through the point -1, -1, and the point 1, 1, but they're going to curve away from the origin at that point. But if we are shifting our graph, then we are going to be using the origin to help us shift the graph. We'll talk about that a little bit later. So those are your notes on basic parent functions. I want you to study these parent functions and be able to sketch them at any time, because it's going to be kind of important as we continue on in this unit.